All right. Happy Thursday, everybody. Good afternoon. I hope you're doing well. Thank you for attending today's webinar, where we're going to take a look at the Creo Simulate and also the capabilities within Creo Simulate Advanced to basically help improve the accuracy and reliability of your CAD models. My name is Rob Romanowski. I'm the Director of Sales Operations for 3HTI. And leading the presentation today and the demo is Paul Dye from PTC. He is an applications engineer and solutions consultant working specifically with the Virtual Center of Excellence. So if you're new to our webinars, we run these Creo webinars every Thursday at noon. And we keep running them because people keep showing up, and we get a lot of positive feedback on the webinar. So we appreciate the feedback, any feedback, to help us make the webinars better. So without further ado, I'm going to pass the controls over to Paul and let him take it away. Paul, it is all yours.
All righty. Thank you very much, Rob. And thank you everybody else for hopping on. So again, my name is Paul Dye, solutions consultant and application engineer here at PTC, and excited to go through here and talk about Creo Simulate. If you've worked with older versions of Creo or even Pro Engineer in the past, you may have thought of this as Mechanica. It's what it's used as the engine for Creo Simulate. But I'll go through and explain exactly how it works, what it looks like in the context of Creo, some of the main capabilities, and some of the distinction between what you might want to use in terms of just standard capabilities versus what areas or what types of people might want to be working with some of the more advanced capabilities. But before I go through and talk too much about everything that Creo Simulate can do, one of the things I want to hit on first and foremost is some of the different challenges that we see out in the industry and some of the things that we really look to solve. And when you look at analysis and FEA in general, it's typically seen as something that only the experts really do. It's not something that your designers manage. It's something that I just build the parts, I send them off to the analysts, they tell me if it's good to go or not, right? It becomes more of a process of I create the model and then you tell me if it's going to work, right? Where it should be more of a collaboration. We're working more towards an ideal design rather than just a pass or fail, right? If you have a part or a model or an assembly that simply just passes, well, it might be over-engineered. It's probably more likely to underperform and cost more money in the long run. So it's still something that we need to be able to do and something that we want to integrate into that design process. And where it's done right now, we see is just too far along, right? If something fails at analysis, right? Your model is probably pretty far along in the design process. It's going to cost a lot of time, a lot of money to go back through. I try to run through that again. It'd be a lot better if we could start to incorporate this throughout the process and really integrate that into the design work that we do. So that's the idea with Creo Simulate, is really an embedded solution from within Creo Parametric. And it is our traditional analysis tool to take the things that we're designing, our parts, our assemblies, our models, and start to understand the changes that we're making and try to work towards a better solution at the end of the day. This includes a lot of different capabilities. I'll go through and talk to them, but starting at your base, things like structural thermal analysis tools to really help us understand how our models are performing, start to really optimize on the model. I'll talk a little bit about that, but the first and foremost biggest thing about this tool is that it is seamlessly integrated with Creo Parametric. It's just click away and really start to change our mindset while we're designing, right? It's something that we can essentially do concurrently while we're going through and building out designs. And it's going to help us to move more away from that pass or fail mindset, where we actually want to start to improve on the design and start to go through and try out new things and start to incorporate that into more of a mindset from the beginning. One of the things that helps us to do that is using optimization and feasibility studies. So feasibility studies is telling me, first and foremost, is my design even something that's possible? Is it something that we even want to keep working with? And if so, which variables or dimensions can I change to maybe maximize on strength, but minimize on the weight? Right, so that's where you start to get a little bit more into your optimization side of things. I'll go through and show what that looks like, but what we've really done is build up Simulate with the designer in mind, right? We don't want you to have a PhD in analysis to be able to use Creo Simulate from within your designs, right? We want the designer to build something out and really understand and know that it's the right design, not just something that we're going to hope that it works. And we have a full suite of capabilities here with Simulate, everything from your standard static structural analysis that plays into buckling analysis. Also, same thing over with your thermal. It's going to give you all those capabilities and plays into a lot of different areas like nonlinear contacts, isotropic and composite materials. We're seeing those more and more out in the industry today, and even some more advanced capabilities. And I'll go through and talk to exactly where these play a part within our packaging, but it really gives you anything that you would need from a design perspective. Large deformations, pre-stresses, dynamic, nonlinear thermal, even areas like fatigue analysis is something that Creo Simulate is very good at covering and that we have options around. So essentially anything that you're going to want to study from within your designs, from within your models, your assemblies, we're going to have you covered. We're going to have a way to go through and analyze a lot of these cases. And almost kind of a dirty word that designers run into a lot of times whenever they think of analysis is meshing. It's something that normally the analyst likes to keep to themselves in their world and something that they're very good at. Well, that's completely fine because Creo is all about automatic meshing. It's still giving you all the same accuracy and still giving you all the same capabilities. But what Creo is able to do with Simulate is build out that optimal mesh so you don't have to. And if you really do want to, you're able to override the system and you can still have full control over that mesh. But if you simply just want to get a model through and want Simulate to do that work for you, you can allow that, right? It's going to work not only for all the solids and all the geometry that you built out, it works well for idealizations like shells and springs and beams. Those are all things that are built into Simulate and all things that you can utilize throughout the process. And optimization studies early and often in the design process, not only just as a means of validating the design and use it as a prototyping. So help us to understand what properties that we can change to improve those designs and gain a deep understanding of your model overall. And from that standpoint, once you've gone through and run those optimizations, you have a lot of functionality whenever it comes to observing the results. And I'll go through and show what this looks like, but automatically Simulate is going to build out templates that give you information on what you're interested in, whether it's stress, displacement, a lot of other values that you can pull up for that. You're able to output that out into different reports, different file formats, Excel, TIFF, VRML, whatever you need in that sense. And also with the models, you can query on those result models to see exactly what those stress values look like or how exactly the parts are going to deform, use animations, whatever you might need from that point perspective. And then also a lot of plotting options that you can go through and detail how the part's going to perform, all designed to be easy to work with and easy to share and collaborate with others. And very quickly, what I want to do here now is just give you a bit of a breakdown of some of the different areas and some of the different flavors of Creo Simulate from what you have within the context of Creo. Now, just out of the very basic package of Creo, you do get access to a few introductory capabilities that you would have around Simulate. And it's going to cover what you have from structural analysis on both parts and assemblies. And essentially what you are limited by is the size of your model. So once you reach a certain number of surfaces within the model, and it's not going to allow you to go through and run it. This is really good just to understand some of the basic capabilities around Simulate. But once you actually want to start to run these types of simulations, I would recommend going up to your standard Creo Simulate extension. Gives you all those capabilities, it removes any bounds that you have for the models or your assemblies, and also gives you a lot more capabilities, things like buckling, thermal, idealizations, design optimization, a bunch of areas that is really going to enable you to do a lot of your main use cases that you would typically see around simulation analysis, things like that. And now whenever you see yourself working with this on a bit more of a regular basis, or there's some capabilities that you want to include beyond that, that's where we start to recommend your Creo Simulate Advanced. This is really going to be geared towards people that are engineers that might be running analysis on a more regular basis, or even your analysts that need a more specific tool and all the capabilities available to them. Well, that's whenever you'd want to start to include some of these capabilities, like your nonlinearity, your composite materials, large deformations. That's what you're going to be working with from a Creo Simulate Advanced perspective. All right, so I'll leave this up for a second just so everybody on the call can take a look through here, see what areas might be important to your designs. If you have any questions around any of these specifically, feel free to drop that in the chat as well. But what I'd like to do now is go through and show demonstration of some of these capabilities. We can go through and see what this looks like here from the context of Creo. Let's go ahead and get started. We're over here in our Creo environment, and what we have is a model for a machine press. This is all held together by a big metal frame. And on this frame itself, you can see we have some brackets up in the corners that maybe we use to mount over in the shop, and something that I need to build out. I've used this bracket in another design, but not necessarily in this particular context. So I need to make sure that it's going to work. And what I'll use to do that is Creo Simulate. Right? We have here this older design that has some pretty good geometry built on, but we need to go through and make some changes to it. So again, this is not a different window or different, it's all available within that same user interface. And you can see a lot of the main things that you'd be using to go through and lay out your studies, things like your different loading conditions that you can go through and define, different constraints, material options, and we can start to go through and apply some of these. Now, first and foremost, lay out a few different constraints. In my case, I know the edges that we need to weld this down by, so that's where we're going to hold the part for our simulation. A few other things that you could add in for predefined translations or rotations as well. And next we can apply some loads. In this case, I'm going to go through and simply just lay out a force or a moment, but this could be also pressure, bearing, gravity, centrifugal forces, whatever you want to apply from that sense. And we do have some more advanced options. If you wanted to, say, for example, lay out a point load, if we wanted to give it a little bit more of a torsional or a twisting force, we can go ahead and lay that out here as well. And if we zoom in there on this attachment, we can see that it's been applied visualization. And now that I have my loads and constraints, we're good to go ahead and run the study. And we also have a material applied there as well. But from this perspective, you could do static, modal, buckling. You have all your different options available. In my case, I'll just stick with a standard static analysis. And we'll use those constraints and the loads. They've already been automatically populated there. We can go through and change exactly how we want to run this as well. So you could do what's called a multi-pass adaptive study. And this is essentially going to allow us to let the study run multiple different times and use different iterations of the model to go through and analyze it to a certain level of convergence. And you can define how exactly accurate you want this to be. So if you want it to be a very low level of convergence, you could define that. Or if you just wanted it to be a bit faster to run, a little bit more coarse, we can go ahead and just lay that out to a lower value. And in our case, very quick to go through and run that through our analysis, and we can go ahead and look at the results here. It's going to give us first and foremost a template. We have an animation of the displacement over on the left with a lot of different options for what we want to plot out in the part. So here, for example, if I want to look at these stress values that we're getting, go ahead and check those out. See, we're getting just around 19,000 PSI. And I know just from experience that this is going to be too much for our particular part. We need to go through and make some changes. And looking back at the plate, I could go through and try to modify it myself. Maybe I have initial ideas about just making it thicker. But if this is maybe getting mass produced, maybe you're also concerned with the weight. That would make the part too heavy. So what I'm going to do instead is try a sensitivity study. And what we're essentially doing is we're running the analysis, but whenever you run it, we want to change something. Right. So in my case, I know that I had a high stress in that filleted region. So I want to understand what happens as I iterate on that radius. And now the difference is, instead of me having to manually go through and iterate on those values, I can just let Creo do that and give it a particular range that I want it to do that within. And we can go through and run back through here to understand exactly what types of values that we're getting. So in my case, I'm interested to see how the von Mises stresses are changing. So here visually, I can see as I'm changing that fillet radius, what our stress value is going to be. If I wanted to get to example 11,000 PSI, I would have to get a radius of 0.4. So actually double what we had before. Now from here, I have some different options. I could go back into the part. I could go through and change it. I could let the system give me the exact value and have that automatically applied. But in my case, I don't want to just simply make the part thicker. I don't want to just over-engineer this. I want to also optimize on this as well. Right? So with an optimization from within the context of Simulate, you'll need to define some limits. And like before, like I mentioned, I know that I can't have stress values above 11,000 PSI. So we'll go ahead and pull that in here as well. And it's easy to go through and define those. But in this case, you could have more than one goal, right? Maybe I'm also worried about the bracket warping. So maybe I'll want to put a range on displacement. Say that can't go over 0.0015 inches. And now that I have a few different limits that I don't want the study to exceed, we can give some values that the system is able to play with. First and foremost, we'll include a fillet size for that. And now what I could do is I could just say go, right? Find the optimal radius that matches our limits. But looking back at the design, there's really a lot of other things that we're able to utilize as well. And that's something that we can go through and include here as well. So if we wanted to give it options to change the certain height of the tab or the width of the bracket, the length of the bracket, the overall thickness, whatever you want to give the study. And the idea is that we aren't taking all this time by trying to figure this out, right? I'm just simply using this spreadsheet down here at the bottom to enter in these different bounds for the study. In my case, I can tell the system how big the tab can be. I know exactly that it can be a certain dimension at the top or the bottom. Maybe we also know exactly how big our radiuses can be. If we have certain angles defined in the model, we can define that as well. So again, just let the system do all this tedious work for us. We don't have to go through and manually define all that. And really, again, looking back at the process is just first and foremost telling the system what your design goals are. In our case, we want to minimize on the mass. And next, we can tell the system the bounds for the study, exactly how high or low each value can go. And then finally, say what dimensions variables that the system can utilize. And again, for us to manually iterate through that could take hours, days, could take a whole week for us to go through and figure out a piece of what we're doing here. And instead, we're just letting the system go through, try out all these different kinds of designs and see if our design limits are satisfied. And using however many options that we need to get within that limitation that we set. And here we can go through and check out our optimized design. And this is clearly a lot different than it was before. Obviously, the fillet size increased, the tab size decreased, but at the same time, we were able to reduce the mass as much as possible. And from here, you're always able to go back and review some of the steps that Creo took to get to this design. It's reviewing this optimization study. And with each step, you can see exactly what that study did right on the top of the model. So lowered that tab height a bit, it increased the fillet radius, and looks like it's kind of shrinking the part overall, but at the same time, maintaining all the structural requirements that we need for that bracket. So that's really how we want to be utilizing Creo Simulate, regardless if we're just doing a standard structural analysis or even all the way up to your full scale advanced style runs, right? Don't just look for a pass or fail out of the model. Look to optimize on it and get, at the end of the day, the best possible model that goes beyond just the simple requirements that you might have laid out for you. Right. So again, after having seen it, it's very clear, obviously, a lot of the main benefits that you get from this, first and foremost, cutting down on the amount of rework that you need to do. You're able to find flaws a lot earlier on in the design process. You don't have to go through and build out expensive prototypes in order to do that. A lot of times those can be very costly. So even if you're able to reduce your prototyping phase or iterations by one, that can really save you a lot of money. And again, that can cut costs on by figuring out exactly what's essential to our design, see what we can remove, see what we can do to really optimize that model. So things around life cycle costs, right? If we're catching the flaws earlier on in the design process, they're not showing up in the prototyping phase. And even worse, if you had a problem that would show up post-production, you have a recall, well, that's another layer of protection against something like that. So at the end of the day, just more quickly, more efficiently get our products out to market and ultimately setting out the best products with them. Okay, so that's really what I wanted to go through and show there around Creo Simulate and some of the different capabilities that we have there. Again, it really has a lot of different options depending on what you're looking to do from a day-to-day perspective and all the things that you're looking to simulate as well. So just at the end here, while we're wrapping up, I'll go ahead and leave up that breakdown real quick so you can have a glance through to see some of the differences that we have between the different flavors of Simulate. But with that, I can go ahead and pass it over to you, Rob.
Sounds good. Hey, nice job, Paul. I appreciate it. So one of the things that we want to, I guess, convey with this webinar is that this tool is made for the designer and the engineer. This is so that you can make these, you can design for function, not just for form and fit, but also for function. And yes, it does take a little bit of training to understand how to use this, but it's not a painstaking process. This is not like an advanced this is not a tool like an advanced simulation tool that needs a specialist where all the meshing needs to be done manually. A lot of the work is going to be done automatically. Now, if you have a design team, what this is going to do to help, or not a design team, but if you have an analyst downstream that handles these types of things with advanced types of software, this is a great tool to have up front, because then the work is not going to come back to you. If you don't have an analyst on staff, this is a tool that you need. This is a tool that's going to help you. It's going to be that tool to do it all for you, for your products, and keep you from having to go back and redesign and reduce prototypes and everything else. So we also do 2 hours of desk side coaching. So if you need the desk side coaching and you're a customer, we'll help you. We're very proficient at getting people up to speed on Creo Simulate and Simulate Advanced. We have one of the foremost experts in finite element analysis and CFD on our staff. His name is Bill Stickney. The guy's just absolutely brilliant. So, I mean, he's worked with NASA. He's worked with a lot of government entities like the national laboratories and military, U.S. military. So he's seen a lot. He's done a lot. And if there's anything that we can do to help you, just respond to the email that was sent as the invite for this webinar, and we will be more than happy to help you out. So that's going to conclude our webinar for today. Next week, our webinar is going to keep in the theme of simulation tools. We're going to look at the ANSYS simulation tools. Once again, these are made for designers and engineers to be used up front. And then the following week, we're going to have a webinar on Creo Flow. So Paul, thanks again for the presentation and everything today. We really appreciate it. And most importantly, thank you to the audience for joining us every week. Have a great week, everybody, and we will send the recording to you. Thank you.